If a car could travel at the speed of light, the headlights would not work as expected. This is due to the extreme physics that come into play at such velocities. At the speed of light, the energy of the photons emitted by the headlights would become incredibly high. These high-energy photons would interact with the air molecules in front of the car. Instead of simply illuminating the road, they would ionize the air. Ionization is the process where atoms lose electrons, creating a plasma. A plasma is a state of matter where a gas becomes ionized and carries an electrical charge. This plasma, formed in front of the car, would be opaque and absorb the light from the headlights. Therefore, the headlights would be ineffective because their light would be absorbed by the plasma they create. The intense energy would prevent the light from traveling any significant distance, making it impossible to see anything. It is also important to note that traveling at the speed of light is currently considered impossible according to our understanding of physics. The amount of energy required to accelerate a massive object, such as a car, to the speed of light would be infinite. Furthermore, as an object approaches the speed of light, its mass increases, requiring even more energy to accelerate it further. Therefore, the scenario of a car traveling at the speed of light is a theoretical thought experiment that highlights the limitations imposed by the laws of physics. Darkness, on the other hand, is not a physical entity. It does not have a speed or any other physical properties. Darkness is simply the absence of light. It is the state of a space where there are no photons present within the visible spectrum for human eyes. When light is blocked or absorbed, darkness appears. The concept of the speed of dark is therefore meaningless. It's a misnomer to apply the concept of speed to something that is defined by the absence of something else. The perception of darkness can change rapidly, but this change is due to the change in the presence or absence of light, not the movement of darkness itself. For example, when a light switch is turned off, the room appears to go dark instantly. This is because the source of light has been removed, and photons are no longer being emitted into the room. The perception of darkness is immediate, but it is not because darkness is traveling at a certain speed. Finally, the result of being scared to death twice is death. The phrase scared to death is an idiom that suggests extreme fear can lead to death. This idiom reflects the real physiological effects of intense fear and stress. When a person experiences extreme fear, the body undergoes a series of physiological changes mediated by the sympathetic nervous system, also known as the fight or flight response. Adrenaline and other stress hormones are released into the bloodstream, increasing heart rate, blood pressure, and respiration rate. These changes prepare the body to either confront or escape from the perceived threat. In some cases, the stress response can be so overwhelming that it leads to a heart attack, stroke, or other life-threatening condition. While it is rare for someone to literally die from fright, the physiological effects of extreme fear can certainly contribute to death in vulnerable individuals. If someone were to experience a level of fear that could hypothetically cause death, then experiencing that level of fear again would, logically, also result in death.